All right. Okay, does it show a recording for you guys?
Yes.
Okay, then we're good to go. All right, I have to open back up the overview thing. How did it go for you guys this week or this lesson?
I'm okay.
Some of it was kind of iffy, but it wasn't too terrible.
No.
That's how like when I read through, I was like pretty confused, but okay. And then I watched the videos and then I like felt a lot better about it. So do you guys just want to start into the quiz or do you want to go through any of the preparation stuff?
What do you find for the question D of number 8?
8D. Is that what you're asking for?
Yeah.
I had 35.734.
Wait, 75?
35.
Oh, I was like, I got 35. Okay, yeah, I got 35 also. Sorry.
Maybe I was wrong. I had 38. So
Did you just round it up to 38? Because like I had 35.734. Oh, but I guess 38. Sorry, I was confused because there's a 0.7. Never mind, forget I said that. Okay.
Yeah.
So what did you use for your, like you used that equation, right? The deviation over the population, right? Or like,
actually, I used a formula that was different from what the teacher used. So this is maybe why I got it wrong.
oh.
So what is the formula you used?
Let me show you. I don't know if you can see my notebook here. How can I show you stuff? Okay. I use the what we call a table, and I put the information in it. So this is one example of what I did. And it has the population, where we have the number of observation, and then a x, which is the sample. And then we have inter parentheses x minus x bar, and x bar minus x minus x bar squared. So this is the formula that I used. So maybe this is why I don't get it. Because I was confused regarding the formula that was suggested by the lesson. Maybe after the meeting, I will go deeper in it.
So that the standard deviation.
Most of the time when I don't understand something, I go on YouTube and find a video that may give me a clearer explanation.
Right. I felt like this week's was a little not very clear. Like in the writing, I don't know, I didn't think it was like the most clear. But did you watch the videos that they had linked on there?
Yeah.
Okay, because I mean, I didn't think it was like way clearer, but it helps clear it up for me. But so like, because we're finding standard deviation of the sample means, right? That's what we're trying to find.
Mm-hmm.
Or of the the distribution sample means. So it was the standard deviation. Oh wait, no. What's the O? The sigma. Yeah, that's standard deviation, right?
Yeah.
Okay. Divided by the square root of n, which would be like the sample, right?
Mhm.
The amount of like in this case, it was the amount of students.
Yep.
So
Amount of it was 529.
No, so 529 is the mean. And so we don't even use that number when we're finding this.
Oh, okay. So the amount of student is 10.
Yeah, consider a simple random sample, or n equals 10 students. So that's the number on the bottom that you find the square root of.
Okay.
So you guys want to try going through the quiz, and then hopefully we'll all
Yeah. We can go
feel
to-
better after.
And we can keep helping each other after we're done with the quiz and we're not recording anymore.
Right.
So does everyone have it open?
Almost. Okay. Yes, mine is open now.
Are you good, Maxie?
Not yet. Give me. Okay, you can read.
So I'll start. Question 3 is, when you are taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is right skewed? So it would also be right skewed, right?
Yeah.
If the parent population is?
Yes. Unless it like specifically says that it's normally distributed, which it didn't, right?
Yeah.
That's what I don't understand. Unless the number is really big or it says it's normally distributed. So it would be skewed right.
Yep.
Okay. All right, I'll take the next one. When you are taking a sample size of n equals 100, what is the shape of the distribution means histogram when the parent population is right skewed? So this is when it becomes normal, right?
Yeah, because of the number.
Because the number is so big.
Yeah.
Okay, so normal. All right. You want to take the next one, Maxie?
Yeah, and when you are taking a sample size of n equals 5, what is the shape of distribution of means of histogram when the parent population is normally distributed?
Then it would also be normal.
Yeah.
Okay, so number 6. When you're taking a sample size of n is 100, what is the shape of the distribution of means histogram when the parent population is normally distributed? Again, normal.
Yep. Okay. When the distribution of means when would the distribution of means be normally distributed? So choose all that's correct. Data are drawn from a population that's normally distributed and the sample size is small.
Yes.
Yes.
Okay. Data are drawn from a population that is normally distributed and the sample size is large. Yes.
It's true. Yes.
Yep.
Data are drawn from a population that is right skewed and the sample size is small.
No.
Okay. And then data are drawn from a population that's right skewed and the sample size is large. That
Yes.
would be normal, right?
Yep.
Because it's large. Perfect.
So those three.
Okay.
Which of the following gives the best explanation of the central limit theorem? If the parent population from which the data are drawn is normally distributed, then the sample mean X bar will follow a normal distribution.
Nope.
For bell-shaped data, approximately 68% of the data will be within one standard deviation of the mean. About 95% of the data will be within the two standard deviation of the mean, and approximately 99.7% of the data will be within 3 standard deviation of the mean.
No.
Nope.
If the sample size is large, the sample mean will be close to the population. I think this is our guy. What do you think?
I think it's the next one.
If the sample size is large, the shape of the distribution sample will be approximately normal.
Yes. I think that's it, because the law of large numbers is the other one that you just read, right?
Mm-hmm. Yeah, this one's the central theorem.
The third one is the law of large numbers.
Yeah,
Mm-hmm.
because that just has to do with like the one mean, and the central limit theorem has to do with like the whole. I don't know if that
overall shape.
actually made sense, but then my mind does. So, okay, so we're agreeing on the last one there.
Yep.
Okay.
So the next one, let X be a random variable with population mean of 10 and a population standard deviation of 6. Suppose a sample of size n is 36 is drawn from this population. So, wow, that just seemed really weird. Suppose a sample size of 36 is drawn from this population. What is the mean of the distribution of sample means?
Okay, so that's what we had been.
That's what we were talking about before, is this
Right.
what this equation is. So that's
Okay.
when we do
6, right? Divided by
the square root of 36.
divided by the
Square root of 36.
Don't worry, Mother. The gold mine isn't worthless after all. We found shields in the building. They're very valuable and will save the kingdom.
So that would be 1.
right. That's what I got. I was using my new, or it's not like new calculator. I was using my phone calculator, so it was weird for a second. But yes, 1, because the square root of 36 is 6. That's what I got. Is that what you got, Maxie?
No, I am behind in my understanding.
So
This is maybe something I'm gonna do on my own when you guys go.
Well, so we can still give you the formula. You can go study it further.
Okay.
But the formula to find the mean of the distribution of sample means is the standard deviation divided by
Standard deviation.
the square root of your sample population, right?
yep,
Which is n.
yep.
So for this problem, we did 6 divided by the square root of 36.
Oh, okay. I squared it, but I didn't square rooted it.
Ah.
I am very bad.
All right, Becky, you want to do the next one?
Yep. What is the standard deviation of the distribution of sample means?
Actually,
So, what?
nothing. Nothing. Keep going. I just. Yeah. So anyway, that'd be 10.
The standard deviation of the, yes, wait, the standard deviation, isn't that just 6?
6.
Because 10 is the the mean, population mean.
The mean.
Oh yeah.
Okay.
What do you think?
Yeah, I think, or it's 6,
Yeah.
right? Everybody good?
6
Yeah.
is the population standard deviation. This is asking for the deviation of the distribution of sample means.
Oh, so do we have to like do a problem for this?
So that's different, right? Maybe.
What is the standard deviation of the distribution of sample means? Hang on, let me look at the, what is, oh, it didn't ask us that in our problems, the prep problems.
Yeah, just give me 1 second. I think I can.
So are we gonna have to find out like the standard deviation for this?
And
Or,
I'll tell
wait.
you in just a second. I'm looking something up real quick.
Oh wait, did we do that problem, like this number 10 should be 1 and number 9 should be the mean, which would be 10.
Okay, yeah, that's what I was. That's what
Okay,
I was thinking.
so we just got confused. We just like
Yep.
jumped right into it.
That's why I was
Okay.
kind of like, wait a minute, something
So,
off.
okay, so does everyone get that? Like number 9 is the mean, which is just tells us in the question, like it's just number 10, or it's just 10 because that tells us it's the population mean.
Yeah, and then the next one is the one we found, which is
Right.
1. So
The
we
standard
just,
deviation. Yeah, I'm like looking at my notes. I'm like, wait, we already found the standard deviation. Okay. We got that, everybody? Good.
so
Okay.
9 is 10 and 10 is 1.
Yes.
Got a little ahead of ourselves, I guess.
Yeah. We got too excited. Okay. You want to read 10, Maxie?
11. We're on
Or 11? Sorry. Oh my gosh. Number 11.
We're struggling today.
Okay. I can read it. Regardless of the distribution of the population, if the sample size is large and is greater than 30, what would be the shape or distribution of the distribution of the sample mean? Normal, right? Okay. Then number 12, what theorem would justify your response to the last question?
Hello?
Hello?
Can you hear me?
Yeah, can you hear us?
Yes, I can hear you, but it feels like you are not.
Oh, well, maybe we didn't hear you for a little bit because I just started hearing you now. So if you were talking before, I didn't hear it.
Okay. No, it's okay.
Sorry.
So did you hear about number 11? Do you have questions on number 11?
Yeah, I hear when you were reading it.
So we decided it would be normal.
Okay.
Because the n is larger than 30.
Because it is large?
What was that?
No, I was asking if it is because it is large.
Yes.
Okay. And what theorem justify your response for the last question?
So that would be the central theorem, right? Because
Yes.
that's what says if your sample size is large, then your distribution will be approximately normal.
Yes. Yep, that looks good to me.
Yeah, it looks good to me too. This is what I see in the textbook.
Okay, I'm gonna submit. Everybody good?
Yeah.
Okay, we did good, guys.
You got 100.
Yep.
Great.
So awesome. All right.
So do you want to stop the broadcast?
Yep.
Yeah.